Okay, so sometimes you can write quadratic equations a different way, and it's useful to write it that way. Okay, it's called completing the square. Remember when we had b squared minus 4ac, and we were trying to show that it was greater than or equal to 0. We were always trying to get something to be squared. Why? Why were we looking for something like that? What is that always? In this scenario, we want it to be greater than or equal to 0. Why is that something we'd be looking for? Because it's always positive, exactly. Okay, so sometimes it's really helpful to write quadratics as a perfect square if we can. If we can't write them as a perfect square, we just rewrite them slightly differently. It's called completing the square. Okay, you end up with the perfect square and an extra number out here. Okay, so I'm going to show you how to do it. I'll show you 2 ways to complete the square. Personally, I like the formula better, but it's totally up to you, whichever way you understand. Okay, so I'll give you the formula. So if you have a quadratic, x squared plus bx plus c, to complete the square, you do x plus b over 2 to be squared minus b over 2 to be squared plus c. So you have to get the x on its own before you do this. Okay, now let me just do a few examples and we'll see what happens. Okay, so for example, I'll do this both ways. If I want to complete this square using my formula, that would be a, that would be b, that would be c. Okay, so it would be x plus b over 2. Lovely, to be squared minus b over 2 to be squared plus c. So you end up with minus 8 over 2 is minus 4. So x minus 4 to be squared minus, that's minus 4 as well, to be squared is 16. So now I've completed the square. I have a perfect square here, but I also have a constant. There is another way to do it. If you don't want to learn the formula off, okay? So just write your little or. Now I'm just going to write this over here so I can check that we have the same answer in a minute, okay? Can I get rid of this? Okay, so let's say we're given this. You want to make it a perfect square. So you make it a perfect square by using these two. Okay? Now, it's a perfect square. Square root that. X. Now remember, the product of the two multiplied by 2 gives me this. So what's this going to be? Multiply these two and multiply it by 2 and you get this. So it's going to be 4, isn't it? And it's going to be a minus. Now, if I want it written like this, that means square the first, x squared. Product of the 2 multiplied by 2, minus 8x. Square the last. 4 by 4, 16. Now, I have plus 16, but I want plus 10. What would I have to do to get from 16 to 10? Take 6. This bit equates to the square. Okay, so your answer is x minus 4 to be squared minus 6. That and that are the exact same. Okay, so what you do is you think about what will give you a perfect square, you multiply out the perfect square, and then you think about what do I have to add or subtract to get the original question. Okay, so I had plus 16, I want plus 10, I need to take 6. Okay, formula I think is just easier because you just fill into a formula.
And how did you get from that line to the roots, or to the vacuum?
To here?
Yeah.
This is the perfect square, so I wrote it down, and then minus 6. Okay, so that big bracket is the perfect square.
Did you go through how you got the perfect square then?
I will. Will I do another example maybe? You'd have to learn off that formula. Yeah, if you're using the formula, you'd learn it off, okay?
How do you know when to do that?
So, it's a very specific question that they'll ask. They'll either ask you to show that something is greater than or equal to 0, or they're asking for minimum and maximum values. I'll write out now in a minute when we use it, okay, and what it's useful for. You're not going to do this just for fun. It's not actually that useful. We have calculus to show us other things, but it's just something we do need to know, and it'll be quite clear when they want you to do it, okay? So let's do example 2.
Just the formula, or like does it kind of mean, like, you know, when you're saying if you're completing the square, like is it just the formula, or are you doing something?
I'll explain. Remember I just said I'll write out those things that we actually use it for, and then you'll see why we'd be doing it. Okay? Okay, so x squared minus 6x plus 11. So let's do it the non-formula way, because I think that's the harder one to understand. Okay? So I want to make a perfect square out of these two. So I know that's square the first, and that's the product of the two multiplied by 2. Now, if it's product of the two multiplied by 2, what's actually here? Minus 3. Very good. Okay? Now, let's actually multiply this out. Square the first. Product of the 2 multiplied by 2. And square the last. Plus 9. That's what my perfect square is. Now,
excuse me, would Caitlin Cunningham come to reception now or at the bell, please? Thank you.
I have plus 9, but I want plus 11. Plus 2. Now that bit there is my perfect square, so I just add on the 2. Okay? Or if we're going to do it the formula way, okay, the formula way is going to be x plus b over 2 to be squared minus b over 2 to be squared plus c. Okay, so your b is here, the minus 6. So you get minus 6 over 2 is minus 3. Same thing here, minus 3 squared is 9. Minus 9 plus 11 is plus 2. Same thing.
Would you not want to multiply out the square Or is that what they're looking for?
They're looking for it to be in a square. If you multiply out the square, you get back there. Yeah. Do you finish at 10 to?